Assalamu alaikum guys, welcome. This is Shafat Khan on your screen, and today we are going to start out this series of lectures on past papers, AA level, actually AS chemistry 9701. All right, we're going to do the MCQ papers, right, starting out with 2002. Okay, and we're going to do as many as possible, right? And this is the May June 2002 paper. All right, so let's begin without wasting any time. In 2002, this paper had 1 hour, but nowadays in 2021, you are given 1 hour and 15 minutes to complete the 40 MCQs which are given in this paper. All right, so the paper pattern is almost exactly the same, which used to be tested back then and now. All right, so let's begin. All right, so our very first question starts out from here, right? It says in the radioactive decay of an isotope of lead to an isotope of bismuth, a particle 0x minus 1 is emitted. All right, what is this particle? What do you guys think is this particle? Okay, so this X is actually the symbol. All right, this is some imaginary symbol. Now this number written in the superscript, which is 0 over here, this is actually the mass number. You guys must know this, right? This is the mass number of the element or the particle. And the number written in the subscript over here, this -1, this is actually your charge or the proton number of the particle. Okay, now the charge over here is negative, all right, and the mass is approximately 0. So what particle is negatively charged in here? Proton is positively charged, neutron is neutral, ion can be both positive and negative, so again cancels. Only electron is the best answer. Plus electron has a mass of approximately 0 as well, right? So that's also a reason why A should be the best answer. So that's the answer. All right, let's move on to question 2 now, which says as a simplification, an adult human can be considered to have a daily diet of 1.8 kgs of carbohydrate. All right, the empirical formula of the carbohydrate is given. It is CH2O. Which mass of carbon dioxide does a person, okay, they are asking us the mass of carbon dioxide, of CO2, does a person produce each day if all the carbohydrate is digested and oxidized? All right, so this carbohydrate has to be oxidized. So obviously it will be oxidized to carbon dioxide and water as well, right? So I'm not making the entire equation because we don't even need the entire equation over here. All we need to do is just find out the mass of carbon dioxide, right? Now you've got, this is a question from moles. Okay, you guys can check out my videos on moles concept. All right, I've already made it in the playlist of AS chemistry. Now this carbohydrate that you have, first of all, let's find out the moles of carbohydrates that we have. All right, so we've got 1.8 kg, which is actually 1800 grams. All right, you need to convert the kgs into grams whenever you're doing mole calculations. You guys know that, right? Now moles is equals to mass over mr. Okay, mass is 1800 divided by the mr of or the mass of this carbohydrate, which can be thought of as the mass of this empirical formula, which is 12 plus 16 plus 2, which is 30, right? 0 cancels out and the answer is 60. So you've got 60 moles of the carbohydrate with you. All right, now let me tell you something. The number of carbon atoms is actually the moles of carbon dioxide produced in this equation. Okay, so if we've got one carbon atom over here, this means only 1 mole of carbon dioxide is being produced on the other side, right? So what is the mole ratio between this empirical formula, between this carbohydrate and carbon dioxide? The mole ratio of this carbohydrate and carbon dioxide is actually 1:1, because 1 mole of this carbohydrate, when it's burned in oxygen or when it is oxidized, it produces 1 mole of carbon dioxide, right? That's the basic mole ratio. So if this is the mole ratio is 1:1, although I have not balanced the entire equation, but this is a short trick to find out the mole ratio. Okay, the number of carbon atoms will actually be the same as the number of moles of carbon dioxide that you have. I hope you guys remember that combustion analysis equation, which was CXHY reacting with oxygen, forming carbon dioxide and water, right? In that case as well, the moles of carbon were X, right? So the moles of carbon dioxide produced were also X, right? The number of carbon atoms were X, so the moles of carbon dioxide is X. Similarly, the number of carbon atoms over here is 1, so the moles of carbon dioxide produced is also 1. Okay, although and I've not balanced this equation as well. Okay, okay, let's just balance it. Y upon 2, and then this is going to be x plus y by 4. Right, this is the entire combustion analysis equation, and I would really recommend you guys to learn this. Okay, because this is quite handy. This comes quite handy while solving the moles questions. Now moving on, we've got the moles of carbohydrate that we have, which is actually 60 moles, right? Moles of carbon dioxide will also be the same, again 60 moles. So just all you need to do now is convert the moles into mass, right? What is the formula for moles? Moles is actually mass over mr, right? Mass in grams upon mr. I'm just going to write it right over here. What is the mr of carbon dioxide? It's 44, right? Mass is what you need to calculate, and the moles are 60. So 60 into 44 will give you the answer of the mass, but the mass will be in grams, okay? So you need to convert it back into kgs as well. So 60 into 44 is approximately 2640 grams. And if you want to convert it into kgs, it's going to be 2.64 kgs, right? Divided by 1000. So option D is your answer, right? Hope this makes sense. If you guys have questions, you can leave them in the comment section, and I'll try getting back to you as soon as possible. Right. Now then, moving on, question 3. Question 3 says the all right, I'll just erase this part out, okay, to make some space over here. Right, now what does question 3 says? Question 3 says the diagram shows the mass spectrum of a naturally occurring sample of copper. All right, so we've got copper over here, and there are 2 isotopes of copper, okay, because there are 2 lines in the mass spectrum. Now the first isotope has a, okay, this is relative abundance, this is not percentage abundance, okay, this is just abundance relative to one another. These are 2 isotopes. So what's going to be the total abundance in this case? The total abundance is going to be 7 plus 3, okay, just add in the individual abundances, and that's 10 in this case. Now, once you've added the individual abundances and you've gotten 10 over here, you can calculate the relative atomic mass. Just use a simple formula, all right, that you've learned in class. All right, you've got the first isotope, which is whose M over E ratio is 63, right? You take that and multiply it by the relative abundance fraction, okay? So relative abundance fraction in this case is 7, right? So how to convert the 7 into fractions? So just divide the 7 by the total abundance, which is 10. Why have I taken 10 as the total abundance? Because 10 is actually the sum of the abundances of the isotopes which are available, okay? The total isotopes in this case are 2, so just add the total, just sum up the abundances of the isotopes, okay? Then add this to the relative atomic mass of the next isotope, which is 65, and multiplied by its relative abundance, or abundance fraction, I should say, which is 3 upon 10. All right, why did I get 10? Again, the reason is the same, right? And so the answer to this is going to be 63.6, and that's your final answer, option C. Moving on to the next question now. Now this is question 4 that you have over here, in which a slow stream of water from a tap can be deflected by electrostatically charged plastic rod because water is a polar molecule. Now see, this is a trick question in which they give you a scenario which is actually almost unrelated, okay? Now you don't have to do anything with the plastic rod or something, or the electrostatic, you don't have to do anything with the electrostatics over here, right? Electrostatics was a chapter of your O-level physics, right? You don't need to do that over here again. All they are asking you is that they are telling you that water is polar, okay? And this polarity is what you've done in chemistry. And now look at the question, how basic the question is. Why is water polar? And that's all they're asking. They're not asking you anything about the deflection. They're not asking you anything about the charged rod. They've just given you this diagram to confuse you, okay? So now just tell me, why is water polar? Why is anything polar? Polarity exists due to difference in a property known as difference in electronegativity, right? So let's see what option is makes sense. Molecules are bonded to by hydrogen bonding. Yes, they are bonded by hydrogen bonds, but those hydrogen bonds don't make the molecules polar. It's because of polarity that hydrogen bonds exist. So this option A cannot be the answer. Then moving on to the second option, the oxygen and hydrogen have different electronegativities. Yes, that's the answer, okay? they do have different electronegativities. Oxygen atom has two lone pairs. Yeah, it does, but like what? It makes no sense. Like it has nothing to do with polarity, and water is able to dissociate. Yes, it is able to dissociate into ions, but again has nothing to do with polarity, right? Now question 5. Why does copper wire conduct electricity when potential difference is applied? Okay, copper is a metal, right? And metals can conduct electricity because of the sea of delocalized electrons which are present. A sea of delocalized electrons. So what option correlates with this answer? Bonding electrons in crystal lattice can move. Yes, electrons can move, and they are actually bonding electrons. They are the electrons which are responsible for the metallic bonding, right? So that's the only option that makes sense. Question 5 is A. All right, and moving on to the next question 6. Okay, so this is a question from states of matter. Okay, the gaseous state. We've got a flask X that contains 1 dm cube of helium at this particular pressure. Then you've got another flask with a 2 dm cube of neon at 1 kilopascals pressure. Now they told us that the flasks are connected. Okay, connection actually means that you are adding the volume of X and the volume of Y together. Okay, so you've added them to form a new total volume at a constant temperature. What is the final pressure? I mean, they're asking you the total pressure. All you need to do over here is just use the formula. All right, VT PT, yeah, PT VT is equals to T1 V1 plus T2 V2. All right, Boyle's law. So the total pressure that you'll get is what you need to calculate. Okay, total volume in this case, volume of X was 1 and the volume of Y was 2. So 1 plus 2 is actually 3. Right, what is the pressure 1? Pressure 1 is 2 kilopascals multiplied by what is the volume 1, which is 1 dm cube added to, whereas the pressure 1, pressure 2 is 1 kilopascal multiplied by what is the volume 2 is 2. And then you'll get your final answer after this. Okay, it's going to be 4 upon 3, which is one whole number 1 upon 3 kilopascals. And it's option A. After question 6, we will move on to the next question, which is question 7. All right, now when heated solid iodine, it readily forms iodine vapors. All right, so yeah, you've got iodine solid. You guys know that iodine is a molecular solid. When it is heated, it sublimes, right? Sublimation takes place. It forms iodine vapors in the gaseous state. But still, the molecules are there, right? You guys know that halogens, all halogens always exist in diatomic form, and they cannot be broken down. Or if they are broken down, then they won't exist, right? They won't be stable. So in the most stable state, they have to exist in molecular form. So which information suggests the nature of the particles in the two physical states? Physical states mean that they are actually existing physically, right? They're existing in the solid state as well as the vapor state. So for physical state, they have to be in the molecular form. So molecular and molecular is the answer, option D. Then question 8. Which statement about the standard enthalpy change of formation of carbon dioxide is correct? All right, so we've got standard enthalpy change of formation. If you guys quickly review what formation was, so formation was actually, it was the enthalpy change when 1 mole of a compound was produced, right? Was produced from its elements under standard conditions. So formation of carbon dioxide, enthalpy change of formation of carbon dioxide. What are the elements in carbon dioxide? Element is carbon and element is oxygen. When they both combine together, they'll produce carbon dioxide, and 1 mole should be produced. This is your enthalpy change of formation of carbon dioxide, right? If you calculate the enthalpy change over here, it's going to be the formation of carbon dioxide. Now let's see what option correlates with this. Is equal to the standard enthalpy change of combustion of carbon. Okay, what was combustion? Combustion was actually the enthalpy change when 1 mole of the element, it was completely burned, right? It was completely combusted. It was burned in oxygen. So over here, this carbon atom, this is completely, and it is 1 mole of carbon, right? It's completely burned in oxygen to form carbon dioxide. So this equation actually represents enthalpy change of formation of carbon dioxide as well as enthalpy change of combustion of carbon. Okay, so yeah, option A is also correct, is actually correct. So option A is the answer. Now I won't go on to the other options. Okay, you guys could just go over them. Now, user data booklet is relevant over here. Now, hydrazine was used as a fuel for this rocket fighter in World War II and blah, blah, blah. Okay, it has the following formula. All right, now this formula that you have over here, this is the formula for hydrazine. Now, this formula is important because the question is concerned with this formula structure. What is the enthalpy change of atomization? Okay, what is atomization? Atomization actually means breaking down into atoms, right? Breaking down completely into atoms. So in this case, if I want to break down this entire molecule into atoms, I need to break down all the bonds. So I need to break down the nitrogen hydrogen bond, this bond, this bond, and this bond, and even this bond. So all the energies need to be calculated or need to be used over here. Now, if I use the data booklet to see the bond energy values, let me just give me a sec. I'll just pull out the data booklet. Guys, so all you need to do over here is just add in all the bond energy values. Okay, the nitrogen bond energy value is given in the data booklet. You just add it, and the nitrogen hydrogen bond energy values are also given. All right, and there are actually 4 nitrogen hydrogen bonds. So multiply the nitrogen hydrogen by 4 and add them to nitrogen bond, and the answer that you get will be your final answer. Okay, in this case, I think the B should be the answer. Okay, although I'm not sure, you guys could just check it out. Now, for which equilibrium does Kc have no units at all? Kc actually means product upon reactants, right? Now, in this case, in option A, there's a solid, and solids are not considered in Kc. So the equation over here is going to be carbon monoxide's concentration times hydrogen concentration upon water's concentration. So the units of water and hydrogen would cancel out, but carbon monoxide will still have units, so Kc will have units. So option A cannot be the answer. If you look at option B, in option B, the products upon reactants, they completely cancel out, right? And if they completely cancel out, the units completely cancel out, then that means Kc won't have any units. Okay, so products, these are the products. Okay, this product and this product divided by the reactants, which are CH3COOH multiplied by CH3OH. Now, these two will cancel out and these two will also cancel out, so there will be no units left, right? Since there are no units left, therefore, it will have no units. Option B is your answer. Okay, guys, so that's it for this video. So questions from 1 to 10. All right, we're going to continue with the next 10 questions in the next video. Thank you so much.